Okay, let me ask a few questions. How many of you drink coffee? Raise your hand. Cool, nice. There's a lot of coffee lovers. Awesome. So you probably know different kind of coffee is just different ratio of espresso coffee and steamed milk, hot water, ice, etc. Right? So let me ask some questions more relevant to this conference. How many of you using Kafka today? Assume there are a lot, or otherwise you will not be in this biggest technical conference of Kafka. Then, how many of you query Kafka data using SQL today? Cool, I know this is good session for you. Nice, so there are a lot of ways to make coffees, and there's a lot of ways to query data in Kafka using SQL. Query data in Kafka using SQL, some of them are super low latency, but hard to use, hard to learn. Just like some of the espresso machine is hard to make, but very delicious. And also, you might get certain tools for you, which is easy to use, easy to learn, with nice web UI, even have some storage for the historical, just like you might get a delicious and beautiful latte. So in this talk, we are going to use the analogy of coffee and SQL on Kafka a lot. So basically, you can replace whatever I said about coffee with this SQL on Kafka. The purpose of this talk is not really to sell you a particular type of coffee. We are going to show you a variety of different kind of coffees, and you may like this one, you may like that one, that's all fine. Or even you can drink different kind of coffee in the same day. Like for example, you might have a strong black coffee in the morning to kick off your day, and you might enjoy a decaf latte in the afternoon reading a book, chatting with your friend. Similarly, it's okay for you to choose different tools, even together in the same company, in the same team, in different stage. So, end of this talk, hopefully you can know there's so many different options, and based on use cases, you can choose the one you want. Before we dive into how you can query Kafka using SQL, let's talk about why you should do so. This is some report I randomly found on the internet. So you get the idea that there's a lot of data being generated, and 30% of them are generated at the real time. And you know Kafka is the best data streaming platform. But even so, only 1% of those data are analyzed at the real time. So you can process Kafka without the SQL. Just like you can have a productive morning without drinking coffee. It's really up to you. But you do need to, like, for example, if you don't want to use SQL, you have to call those vanilla Java API from Kafka. Yeah, that sounds very like coffee. But my point is, if you call those a low-level Kafka API, and you have to handle a lot of state management, cache management, and if you want to apply like join on multiple topics, and you have to be very sure you have good understanding of those concurrency and the file system, Linux kernel stuff. So is that doable? I mean, query data in Kafka without SQL? Yeah, it is possible. But it can be challenging, it can be boring. So today, I guess no one really query big data without database. So why you don't query your live data using SQL? So let me double click on this. So why we need a database? Like back in 1960, the database idea is invented, and to separate the business logic and the low-level file system API. And 20 years later, the SQL-based relational database become dominant. And you no longer need to learn a particular API from certain database. The SQL is your common language, right? It become so popular and easy to use. Even different database may have slightly different behavior for same SQL syntax, but it works in a general way. And as a result, you get much better performance by using a database, not handling the data by yourself. Those database is written by those experienced engineer with very good understanding about networking, algorithm, data structure. So you can always rely on them to process, optimize your query. And the database in general is easy to learn, easy to use, and even a kid who don't really have any coding capability, he or she actually can using SQL to process data in the database. And this can be translated to this data streaming space in a similar way. Like why we should process Kafka using SQL, and one reason that is this is reliable. Right, compared to you handle everything by yourself using the low-level API, you have your own beautiful data structure or some of your kind of algorithm. But if you rely on a data processor or streaming database, this handle this for you. You never worry about auto memory, deadlock, or crash, and this become their problem, not your problem, right? And it is faster. You probably know there's no really index in the Kafka topic, and even you want to run certain kind of a filter or flat transformation, changing from this format to that format, removing PI, this can be doable, but if you run this in a true database, it will be much faster. And it is easy to use. And again, it should be okay for a kid who can process data using Kafka, using SQL, without learning anything about the Java API. As a matter of fact, that you actually invite high school interns in my team to process data in Kafka and using SQL, and she did it very well. And it is also will be very powerful, and you can run very sophisticated processing logic, not just a simple filtering or flash transformation. You can join data from different topic, or even from different Kafka cluster, and you can handle like late events. You can apply machine learning with SQL. So it is very powerful to leverage database or leverage SQL to process data in Kafka. And also this is descriptive. So when you process data in Kafka using SQL, you're not really calling those low-level APIs, right? And you are saying, hey, this is what I want to do, not you how to do it. So it can be easily ported to support other data streaming systems, such as like Pulsar, Kinesis, or other Kafka-compatible API. You are not really kind of have such tight dependence to the low-level API. Okay, so hopefully now you buy in the idea of query Kafka using SQL. So what exactly you can do with this SQL on Kafka? And I'm showing you a list of use cases we at Timeplus already implemented in person, no matter by ourselves or by our customers. This is just kind of a small percentage of the use case we support already. It's not really something on the paper, it's there. And if you come to our booth, we'll be more than happy to walk into some of the details. So basically, whenever you have some fresh data, no matter it's like clickstream, IoT sensors, you can build the real-time or streaming app using the SQL. So this will hopefully can give you a better chance to implement your idea quickly, have low TCO, don't worry about the infra or cloud cost. And we cover many of the major use cases from fintech to customer care to the security for the DevOps. Again, there's a lot of different recipes or ways to make a coffee. And I'm not sure, maybe there's a similar kind of different kind of ways to query Kafka using SQL. So this diagram can give you overview about what's the option available for you from this open source world. So no matter it's a streaming database, a streaming processor, or an OLAP database which support Kafka as a source. So we only have about like half hour, so we're not going to talk every single project. So if we miss any logos, sorry for that. We're also going to mention some other option which is not open source but also available in the cloud. And we grouped this by this data streaming processor database, real-time OLAP. And we also group by this the primary language, how those system is implemented. I know this may not mean a lot, but hopefully this means something, right? So let's start from top to bottom, from left to right. And the first one, of course, is Java, and the first one is Flink. So this is my impression of Flink, Apache Flink. It is almost the de facto standard to apply streaming processing on real-time data, right? And it is built on top of the low-level Flink API, step by step, very elegant design. And to connect Flink with Kafka, you can just using this called SQL DDL. You can create a table and you can specify all those key properties in the with clause, right? The the broker address, the topic, the offset. Do you want to get the latest data, or do you want to go back to the very beginning to fetch all the existing data? Or even you can specify what's the format, right? Whether it's a very flexible JSON, almost mean anything. And also you can apply a strong format such as like Arrow or protobuf. So Flink doing this very well, but there's some other caveat you have to pay attention. So I put a very, it's more like personal opinion on this. This is more called like coffee tasting note. Of course, this is not really official, but the idea that is having such more like personal summary for this different project, including Flink and other projects in this talk. So to help you to better understanding different focus on different projects and help you to compare which one might better fit your use case at hand. So let's go over very, very quickly. So community, Flink has also on community, I guess, yeah, David hosts. So there are, I think, over 3,000 active members in the Slack. The process to have new release or bug fix is awesome. And it is low latency. It's at second or sub-second latency. And it is very good on the streaming processing capability side, but not as sophisticated as the low-level API. So using the low-level Flink API, you can do amazing stuff like defining your own watermark strategy, all those stuff, but there's some limitation for the Flink SQL. But again, it is a great streaming processor, but there's no long-term storage. But this can change with the new Apache Pymon project. But it is beyond Flink. And the Flink recently introduced the SQL gateway and the JDBC driver. So you can leverage those stuff to query Flink. But in general, the typical way of using Flink is you leverage Flink to process data from Kafka, from other real-time sources, and send the result back to either Kafka or back to OLAP or S3. Then you can query from there. So Flink is not designed for you to query the state or query whatever happened like 3 months ago. And Flink it supports large-scale deployment very, very well. Some of the published use case they use might be hundreds of, even thousands of nodes of Flink. So it is really battle-tested and very mature. And but in the same time, there's a cost, right? So set up a Flink cluster in production is not easy. That's why we are talking about serverless Flink in today's keynote. And there's a lot of low-level JVM tunings. There's still some considerable footprint. It feels like espresso, right? You can get very good espresso with those fancy and machine, but in the same time, to operate such machine, maintain it in a high quality is not easy. And similarly, that Flink is great for those extreme use cases, but you might have to spend some time to learn it, to maintain it. It may not always be the best option if you just get started to query Kafka using SQL. And yeah, let's be honest, that is Flink. It is hard to learn because of the capacity. So let's talk about KSQLDB. As the name suggests, it's a DB, right? It's a SQL database on top of Kafka. And if you set up Kafka locally or use the Confluent Cloud or Confluent platform, you get both Kafka cluster and the KSQLDB. Just like you buy this tin of Coca-Cola coffee with coffee. So this is the first streaming database we're going to talk about in this talk. KSQLDB this itself is a computing engine, and they leverage Kafka as the storage. So you can create a stream to connect to your topic. They run it in the same cluster, so you don't have to set the broker. You just set the topic name, some format, and you define the schema. So that's it. It is relatively easy to use. And you can also, this is stream, but you can also create a table if you prefer something like materials view to present what is now, as of today, the current state. So the KSQLDB also supports the pull query and the push query. The pull query is something you're very familiar with, the traditional OLAP. You run a query wait for maybe 1 second or 1 minute, depends on how fast the database is, you get the result. And if you want a new result, you have to query again to pull this again. But in KSQLDB, if you add emitted changes to the end of the SQL, then you can get this push query. Based on the new event, you will get a new result immediately without waiting for without issuing a new query. I'm going to show this coffee tasting node for KSQLDB. If you have multiple Kafka cluster, KSQLDB can be a challenge because it's designed to run in the same cluster. So if you want to do certain kind of aggregation or join across your Kafka cluster, you might hit a certain limitation of the KSQLDB. Kafka is not just in memory, right? You have file system, you have cross-site replica, but saving data in Kafka is not really cheap, especially if you are talking about like multiple quarters data in Kafka. So if you choose KSQLDB because they're using Kafka as a storage, you might have to be very careful regarding the cost or set a certain retention policy. And again, as I mentioned earlier, there's no index in the Kafka data. So if you query a lot of data, it can be slow. And also, when you're using KSQLDB, there will be some new internal topics created in your Kafka. So you have to manage extra cost or capacity. And there's also some limitation on the join. So if you have A join B, and you have to make sure both A and B, these two topics have to have the same partition numbers and the same partition strategy. So there are some limitations. So overall, this is the node. There's a few other Java-based systems that can process Kafka data using SQL. So let's go over them very quickly. The Helocast is an interesting project that has been there for a while, and essentially, you get either a single node or cluster version of database, both for streaming and historical, but they leverage the memory, even shared memory. So this is a way how you can define they call map to pull data from the Kafka topic, and you get a table, something like table, you can query it. We're also going to talk quickly about this is real-time OLAP, not really streaming database, not really streaming processor. They are just fast OLAP system like Pinot. So Pinot is a great and fast user-facing analytics OLAP. And to query data in Kafka, you have to move into the Pinot. And the process is a little bit more manual. It's not based on the SQL. You have to define the schema. You have to provision the table and run some API. But in the end, you get the data in Pinot, and you can leverage either the API or the web UI to query data. And similarly, Jove, you get the similar experience, and you can get a nice interface to query them. But again, because they are not really streaming processor or streaming database, if you really needed to get low latency, you either have to query this over again, or you might have to leverage things like Flink or other options we mentioned in the talk. And the other thing I want to mention before I hand over to Gang is Trino. And Trino or Presto, they are even not really OLAP database. A common use of Trino is to do federation search. So you run a query, a SQL query on Trino, it will translate to the low-level API to the underlying downstream system, and you provision this. And I put this image, it's just like decaf, right? When you drink a decaf coffee, there's either no caffeine or less caffeine, and because there's no really storage for Trino, I guess there's certain kind of similarity between them. Okay, cool. So with that, I hand over to Gang, our CTO, to talk about the rest of the open source projects that can query Kafka using SQL. Thank you.
Thanks, Jove. And next, I'm going to talk about the other tools that you can use to query your Kafka data using SQL. The first, I'm going to talk about those C++ solutions. I'm going to talk about the Timeplus Proton, which is a streaming database. I'm going to talk about the ClickHouse and the StarRocks, which is a real-time OLAP. And there's no streaming processor developed in C++. If you know, let me know. I'm not sure if Red Panda will have that, but so far I don't know if there's a C++-based streaming processor. Okay, so first I'm going to talk about this Timeplus Proton. Proton is an open source streaming database. We just open sourced last week, so please do check it out. This is a C++ based streaming database. What Timeplus is doing is actually we want to make your data analytic job as fast as possible. So to do that, actually, we found that a lot of analytic jobs, actually you need query real-time streaming data. Also, you need query a lot of historical queries. To achieve fast data analytics, right? Actually, you have two ways. Actually, one is that actually you can run a streaming query where your query processing is running there continuously, and as soon as your data arrives, we run an incremental calculation and push the result to you. Leverage the existing state. It's super fast, low latency, right? But there is a limitation with this streaming processing is that most of these streaming processing, the data is on some append only log, like a Kafka, right? Your data is on Kafka. Kafka is really good to give you the fresh data, the latest data, but it's hard if you want to query a lot of historical data. Say, I want to query a lot of historical data from Kafka, you actually have to go from some offset and read all the data, because you cannot easily skip some of this data, right? So it's not designed for historical data. Also, if you save a lot of historical data on your Kafka, it means it's also very expensive, right? So another way is actually those streaming, not streaming, the OLAP database or real-time database. So what they do is actually they provide a column store, they provide a fast ingestion, and they provide some vectors compute processing, so that you actually can scan a lot of historical data very quickly, right? Do the aggregation. But the limitation for those OLAP databases is actually because they use some index or technology to save your data, it actually takes time to make your data available for search, right? So that means when you run a query, it's fast, but your new data is not there for you, right? That's why you can see this is a Proton architecture. So our design is actually, the core design is actually a unified storage that covers streaming processing, which is similar like a Kafka, but it's a Proton. We implement our own version of Kafka, and plus a ClearHouse as a historical storage. So with that, we have a unified streaming processing engine that's you can think is our version of Flink. So we combine the Flink, Kafka, and ClearHouse to give you fast query capability on streaming data. And when talking about Kafka, there are actually two ways, right? The first, you can ingest all your Kafka data into this architecture and you can query. And the other way is actually we call the external stream, which means you don't have to save any data to Timeplus. It's more like the Trino that Jove just mentioned. So it's a federation query. We read your Kafka data in the real time and without saving it. So like you can see this SQL script that's created its external stream, and then you can query your Kafka data. So next, I'm going to show you some of those queries. What are those queries look like? First, we call the streaming tail. So you select star from a stream. Here, the sample is a car live data. You can consider you have 1,000 cars. They're sending data to Kafka in real time with sensors. So this select star from car live data will give you tail data. That means every time there's a new event collected from your cars, the data is pushed to you. So it's a long-running, unbounded push query. And historically, like I mentioned, we do support historical queries. If you add a table function to your stream, it actually turns to the bounded query, just same as existing database. And you can do global aggregations. So you just count everything. Every time there's new data, we give a new count of everything. And we can run window aggregations, similar like all the streaming processing, very common ways. And we have a substream, like if you have thousands of cars, we actually can help you to query the data for each car, say what's the current car speed and the previous speed using these lag functions. So you can analyze all the car at the same time. And then there's a late event, right? Usually, if you are familiar with Flink, so we leverage watermark to help you to handle the late event. Like time travel, in this case, it's more like a time reading the offset. If you want to query something, what's happening now, you don't need to specify the time, but usually you need to backfill sometime, say what happens like 2 days ago till now, and then you can specify the time. And last, there's a lot of streaming join for sure. In this case, you actually can join your stream with some historical data to enhance your real-time queries. Okay, we think like Timeplus is more like a mocha, so it's a combination of coffee and milk, so which is real-time data is coffee and maybe historic data is milk. So that's and for talking about the taste notes, so Proton is pretty new, but you can try it. We just open source it. We have we hope we can grow the community. We are very proud that we can contribute what we are doing to the streaming community. It's real low latency. If you can read my blog about our performance test, we do everything in streaming. We stream as the first citizen in Proton, and it's very good historical support because it leverages ClearHouse. And for sure, it's a single binary. It's easy to use, and please try it. So one more thing. So other than the open source version, we have our cloud version, so which provide more data source, data sync, and a better query console. And this is the data lineage and dashboard, right? It's Timeplus is more like an end-to-end data analytic platform, other than just a streaming database. Okay, as Timeplus is built on ClearHouse, actually I'm going to talk a little about ClearHouse. You actually can use ClearHouse to query your Kafka data, right? So this is a ClearHouse leverages engine, right? The table engine is called Kafka. And then you can directly create your table in ClearHouse directly Kafka without ingest anything, similar like what Timeplus do. So the difference is that it's not a streaming, right? It's still a batch. That means ClearHouse will read all your data on Kafka, do a query for you, and in a batch way. So you don't have when there's new data, ClearHouse doesn't know, so it doesn't handle streaming. But if you are running a batch of your Kafka data, you can use ClearHouse. And of course, the ClearHouse does support a lot of databases use Kafka as the ingest source. So I think today, ClearHouse here talking about their ClearPipes, which is leveraging Kafka to ingest data. So that's a different ways, right? Instead, so you actually have two ways to do query Kafka. One is ingestion, one is without ingestion. And the other, compared to the other one, is StarRocks. StarRocks is another C++ based OLAP database. It's actually originate from another Apache project called Doris. So you can, in this case, if you are using StarRocks, actually you create a routine load. This routine load is like a background processing, reading your data from Kafka and saving to Doris. So I'm skipping those difference compared between ClearHouse and StarRocks. But if you do want to know more, we can talk about that later. Okay, next I'm going to talk something about Rust-based tools. Actually, yesterday I have a talk with Yaroslav. We talk about the Rust. I think Rust is a good one. It's good tools. Community is growing. But my point is that if you recreate something using Rust, that's not very valuable. You need to create something valuable, right, using Rust. So I'm going to talk about stream processor Arroyo. I'm going to talk about Rising Wave and DataBand. Rising Wave is a streaming database. Arroyo is a streaming processor. And DataBand is another Rust-based real-time OLAP database. So Arroyo is something like streaming data pipeline. So if you're familiar with Flink, right, you use Flink. And I think Arroyo is an alternative. Try to simplify Flink using Rust-based architecture. You can create a Kafka connection quickly, and then you build your pipeline. You can do ad hoc queries, and you can preview the data immediately. And then if you are happy with the pipeline, you can publish and run it. So and next I'm going to talk about streaming database Rising Wave. I think if you're familiar with Rising Wave, if you don't familiar with Rising, you probably know Materialize, right? The other streaming database. Rising Wave is another choice built on Rust. It's a streaming database, so you can easily run it because it's open source. You can get the Docker image and run it. It's compatible with the Postgres, so it's easy to use if you already familiar with Postgres. And you can create a table here. Say, for example, this case is a GitHub event. You create a connector with Kafka, set all the settings, and then you get a table, right? And then what's next is similar, like you just run a SQL query with this table. And of course, like I mentioned, Windows is typical streaming processing technology. So you can Rising Wave support as a hopping window, tumbling window for sure. So we believe it's if talking about coffee, Joe said it's a cappuccino. So yeah, it's a good community. Yeah, I think Rising Wave open source like 2 years ago, so they have a very good community. It's it's about real time. For the streaming, actually, all the streaming database support is a materialized view, right? We run continuous query using materialized view. So Timeplus, I think SQLDB, KSQLDB, Rising Wave, all have streaming-based materialized view. But there's a little difference between the historical, because as I mentioned, Timeplus historical is based on the ClearHouse with a column-based database. So it's more easy if you want to scan a lot of data. Rising Wave's historical data, its data is in, I think it's more like a row-based. So it's more like if you have a point search, it's good. But if you want to scan a lot of data to aggregation, I think column-based is better. But this just it really depends on your use cases. Okay, so next I'm going to quickly talk about DataBand. DataBand is actually a Rust-based OLAP database, and it's really has very great performance. If you take a look at the benchmark published by ClearHouse, I believe DataBand is the only one that even outperform ClearHouse. But talking about the Kafka data, actually all these OLAP database, they don't support like ClearHouse has a table engine, but all the other OLAP database, they actually just leverage Kafka as an ingestion channel. So you ingest your data through some tools, and even in this case, DataBand, you have to have a separate data ingestion tools, so you can ingest your Kafka data into this database. So yeah, we talk about a lot of those tools, and a quick summary. If you have stream data pipeline, which is good, and you're actually just processing your data without saving it, right? For the streaming, for OLAP database, you save all your data, but most of this OLAP data doesn't support streaming, right? They just historical batch-based processing. And if you have streaming database, most likely you can go with your pipeline, and you also can do some ad hoc queries. Okay, so and I'm going to hand over to Joe, make some summary, and then we can have some Q&A.
Thank you. Yeah, so we cover quite a lot of projects in a quick way, mainly on the open source side. And if you add more cloud offering or closed sources, there can be more logo add to it. Like for example, Databricks offering streaming SQL on top of the Spark SQL, and the Materialize is one of the first streaming database, and now they more focusing on cloud-only operational data warehouse. And Rockset and Tinybird, they are also great cloud service for you to create a new REST API for the real-time analysis. And other projects like Dozer, Fedora, Pathway, I'm not going to read all of them, but there's a lot of initiative or long-term projects try to make your life easier to process data in Kafka using SQL. And again, this is not a definitive list. Feel free to talk to us if you have something exciting and help us to explore more options. And don't worry about this testing note. The entire slide deck and the recording will be available. But again, I want to repeat that there's no really good or bad coffee, right? There's no really one size fits all. And choose the one that works best for you. And even combine them together based on different stage of your project, your team size, your skill set, or even maybe you're just a coffee taste. And especially when your team or organization already using certain OLAP database, check whether they already have a certain integration with Kafka, and check the benchmark, check the tuning and maintenance efforts. And if you really needed to run complex join or even have some late event processing, then you probably need to choose a streaming database or streaming processor. And if you in a startup company and you have a tight schedule, you don't want to maintain a lot of microservices, you want to simplify your stack and do some easy troubleshooting end-to-end, or even just save costs, then we will recommend you choose a streaming database to unify the real-time and the batch processing. And again, we only cover SQL-based tool in this talk. So if your team is not really SQL person, you guys may prefer Python, you might prefer other tools, feel free to check other projects such as Badwax and Quix. There's tons of different options. So again, there's no really good or bad coffee, there's just different options. So again, the purpose of the talk is not really show which one is more awesome, but give you all the options. And at the end of the day, hope you guys know all the options there and discuss with your team and try some of them. Most of them are available open source or at a free trial. And I think we might get like 5 minutes for the Q&A. Thank you.